So today we've got a couple of presentations. One from Keith about what Megaport's doing with AWS and their pretty awesome dial your own bandwidth, and Nick coming to talk about how he decouples different application components in this design. So we'll kick off with Keith, and then we've got Peter.
Hey guys, I guess first of all, who knows anything about Megaport? Apart from Zip. Okay.
Could you stay here for the camera?
Oh, okay.
Cool. Just drop in the mic. You drop in the mic.
Okay, I'll start with a little bit of history about us. So we started off in 2013, and our founder at that stage was Bevan Slackery, and he owned Next data centers in Australia. And he was getting frustrated with the telcos that he couldn't dial bandwidth up and down or choose the bandwidth he wanted. So that's where, from there, we listed a couple of years later on the stock exchange in Australia, and from there we've just grown globally at a hell of a rate of knots. Why did that jump three slides at a time? Up until basically this last week. So we're now connected to 660 data centers around the world. Out of those, 380 of them are ones we've got our own equipment in. The others are all cross connects because they're big campus style networks and that sort of stuff. And as you can see there, we're now on the ASX 200 in Australia. Through COVID, we brought on a few markets. We brought on France, Italy, and Spain through the lockdown. There's a few other countries were meant to be on board, but we had a few problems getting the telco circuits in there, as you can imagine, at the moment. So what do? We provide an SDN network, so a software-defined network. So, and what we're doing there is we divvy up the bandwidth that you want. So let's say you want 50 meg to AWS today. You can dial up 50 meg. If you want 100 tomorrow, you can dial up 100. You pay for what you set that market at. So if you want 50, set it at 50. Through the night, if you want to set it at 1 meg, so you're not paying for any bandwidth through the night, we give you that option too. So you through APIs, etc. We connect to most of the cloud providers. In fact, I think there's 350 odd service providers we connect to globally, and that's sort of giving our customers a big range of where to go and what to do. The whole story of what we're here is really around pay for what you use, and also make it easy. So everything's point and click, and with the portal you can control the bandwidth you want, or you can use open APIs. Everything's secure, so it's just like buying a GWS link or one of those sort of things from Spark or Vodafone or equivalent to that, and then connect, as I said, to all the users. We don't do the last mile, so we only do data center. If we need to get you into a data center, then a last mile into a meet me room and a cross connect to us. Most of the data centers that we're connected to allow us to do that as well. This is really our network as a service, so there's no upfront install cost. The only upfront install cost you've got is cross connect in the data center, of which you'll need to connect to anyone. So once that's done, we're away. Once that plumbing is complete, you can then provision a circuit anywhere in the world within a minute. I was going to give you a demo, but with everything not working, I'm having a few problems connecting at the moment, so I'll do that afterwards if we can. As I said, capacity, you can dial up, dial down. We give you a whole range of open APIs that you can turn it off at night and turn it back on in the morning. There's a very large council in New Zealand who has about 800 meg going to AWS through the day and turns it down to 300 meg at night. That saving is about $2.5 grand a month by just that one saving alone. So that's sort of giving you the scale of what you can do with them. Everything's on a month-by-month contract, although we do give a couple options around 12 months and 36, but 90% of our customers would take month-by-month contracts. We're not tied to any data centers or any providers, so we're not linked to AWS or Google or anyone else. We're not also tied to Equinix or any of the other data center providers. We basically handle all, and the whole thing's very much around the ease of use. I guess all I'm showing here is that, and this is where most of our customers are. Most of our customers are hybrid. In fact, most of our customers probably have 2 or 3 of the cloud providers at this stage. Our value proposition, I sort of said, we've got about 1,800 customers at the moment, and we don't do the last mile, but from the data centre. Our value proposition is really around the scalability, being able to turn it up and down as required. Connection, I'll talk about a product we've got very soon around that. It's all secure and private, and it's all very flexible terms. Our network at the moment, we were born in Australia, so we've been going out the rest of the world. So this is really our backbone at the moment, which is spreading across the States and through Europe. And then these are the locations we got on board today. So you'll see here we connect to 13 data centres in Auckland and 2 in Wellington. And where the red ones are just the one-offs. So we've got a site available in Dubai, for example. At the moment, we were meant to be going to South America right now, but with what's happening in Brazil, we've actually pulled the plug on Brazil right this minute. In the next 18 months, the real area we're looking at is this sort of area here, and you'll see a lot of growth from us coming into China and India. Planning's well underway for those at the moment. It's just going to depend on how COVID sort of cuts our wings on that at the moment, I guess. On-ramps. Biggest part of what we do is obviously on-ramps. So you'll see there we've got 50 AWS on-ramps around the world that you could connect to. Why is that important? If you're doing a development with, let's say, an organisation who's based in Chicago, you can run a 10 meg circuit from New Zealand to Chicago for under $300 a month. So that then means if you want to test applications on the other side of the world, nice and easy. If you need 10 meg to London, it's about the same. It's $280 by memory. And that's sort of we're sort of breaking those barriers down. If you're looking at just Trans-Tasman as we were before, 100 meg to Australia is about $700 odd a month from New Zealand here. And if you look at the likes of picking up from your standard telco provider, it's around about $3,500 to $4,000. So there's quite a saving there to be done. Our portfolio is really easy. There's a port in the data centre. It's either a 1 gig port or a 10 gig port. And from that port, we then have what we call a cloud VXC. And what that's allowing us to do is you're not buying a port at the data centre, let's say at SY3 in Sydney, to connect to AWS. We've already covered that. So that's what we call our cloud VXC. We can though do a data centre as in a straight telco pipe that you'd buy from anyone, which we call a transport VXC. We bought a company about 3.5 years ago in Europe, which was a peering exchange in Germany and one in Bulgaria, and we basically implemented the technology we got on that around the world to give us a peering exchange. We've got one in Auckland, we've also got 4 or 5 in Australia and throughout the world. And there's obviously some benefits I'll cover in a second around why peering exchange, etc. So everything in that top part is all layer 2. We do have one layer product, which is a cloud router. The aim of the cloud router is if you've got multiple clouds, but it works pretty well for New Zealand. So instead of having, let's say, in the past let's say you've got AWS, Azure, and Google, and in the past you'd order 100 meg circuit to each of them, because that's how we were brought up. Work out the maximum bandwidth you need, not what you actually require, and then put pipes to them. What the cloud router does is reduces that so that the instance is sitting on servers in the data center. So anything that's sharing information does it in the data center, and you just bring the results back. One example of a customer I've used on this who was connecting to 4 clouds, they initially told me they needed a 400 meg connection, and I said, nah, no way. Today it's sitting at 130 meg because all the data they've been able to cut down just because of the size of the pipes, etc. So, a couple other things you can do with the multi-cloud router, which are a little bit unique. And unfortunately, it's the opposition's product. But if your router doesn't handle Q&Q, then that box handles Q&Q. It also handles the ASN number if you don't have a public ASN number yourself. So there's a few ways to get around some of these bits and pieces. Connections models, as I was sort of saying before, we can do data center. Most of our customers are either here, data center cloud, or data center multi-cloud. You can actually use the cloud router without having a connection to anything else. So if you're 100% in the cloud already, I've got one customer who takes information from one cloud and transfers it to another cloud in the States just using our cloud router. So he basically dials up a cloud router for a day and then turns it off straight afterwards, which is, I think it's cost him about $20 every time he wants to do it. So If you need any of these, Keith, I can give it to you after. How the port works within the data centers, we have a physical cross connect from your firewall or your suite into our switch, and then we allow you to do that switch up to 100 times. So that means you can have multiple connections to multiple clouds. You can stand up a SAM pit in AWS for a couple of days, run it and then turn it off, etc. Ports, as I should have mentioned initially, ports are charged on a monthly basis in advance, and data is in arrears. So, because obviously you can massage the data from 1 meg up to your port speed, so you can have any volume of speed you want through there. Cloud router, as I said, the main advantage of our cloud router is more around localizing that traffic, the cloud traffic, and really good for hybrid cloud. So these connections can be all at 1 gig coming into the switch, for example, and then from the switch you can then have 200 meg or whatever you need as your capacity back. Where that works out really well now is with hosted connection, where you need 1 or 10 gig connection to it. So if you do that in the data center, most of our customers in New Zealand probably can't afford a 10 gig from New Zealand to Sydney to hook up to hosted connection, but our system allows you to then massage the amount of traffic you've actually got going through that at the end of the day, so you can raise or lower that as required. As I sort of said, this is all around keeping it within the data center. When you sign up, you've got a choice to belong to a marketplace. The marketplace that we set up is very much around working out other people who are in the marketplace you might want to connect to. For example, you might want to connect to BNZ as your bank, so instead of using your connection and getting your information off the bank, you could have a VXC between yourself and the bank. And it's basically just saying, putting a hand up, we're here, and these are the locations that you can pick us up from. The other part, as I mentioned before, was around the peering, and with the internet peering, there's a number of ways and a number of things you can do here. Obviously, AWS has mentioned that it's working on bringing peering to New Zealand very soon, and we're working with them at the moment about putting that through our AX as well, globally. But one of the advantages you've got with peering in New Zealand here is if you're a large organisation and you're connecting to, you've got 365 traffic, for example, you can peer with Microsoft on your 365 traffic, therefore taking that off your internet gateway. If you're someone like MSD with 8,000 seats, that's a lot of traffic you're taking off an internet gateway, so you can literally save thousands of dollars there if you can do it that way. Other things you might want to peer with through the peering exchange might be things like Zscaler. Zscaler in Auckland sits behind Lightwire, sits behind Vocus in Australia, and therefore you can pick up applications, etc. via peering as well. I've just put the AWS one up here only at the moment, but we have the options of picking up everything in any of these regions around the world, and you'll see some of these got little marks behind them. That's really for the hosted connection, so we can give the orange and the blue side as well, so you can have diversity within the data center as well. I've got them for all of the other cloud providers if anyone's interested to talk later. New Zealand, these are our on-ramps in New Zealand at the moment. So we've got the 3 Rivera ones, 3 Datacom ones. We split Merrill Drive a little while ago because we were having a lot of problems getting third-party organisations into the Spark data centre. There's more bloody mindedness than anything else. But anyway. So they're our current ones. We're looking at putting potentially another location in Wellington soon and one in the South Island. So we'll then have a few more locations up there. And for any of you interested in Australia, they're our main players that we deal with in Australia. Okay, any questions there? Because unfortunately, with my demo not going, I'm going to, I can do that at another stage if anyone's interested.
Okay, do you have many customers who layer like a VPN or tunnels over the cloud router?
Yep. There's a lot of customers, and the cloud router can be used for multiple different things. I mean, every day we come up with customers looking at it for different ways. I've got one customer who's looking at bringing it, using a hub and spoke for their voice and data in Europe. So bringing a whole lot of sites into a cloud router in London and then just bringing a single pipe back to New Zealand instead of bringing, in the past we bring multiple pipes back and forward. So the cloud router is expanding every week. One product we are looking at adding, we call it a Megaport Virtual Edge. and we'll announce that in 2 weeks' time, I think it is. What that's going to allow the cloud router to do is become an SDN hub. So that means like your branch offices for a bank, your branch offices will come in via Meraki, and then they fit on the backbone with everything. Yeah, through SD-WAN. So most of our development is going to be on those sort of products at this stage. Any other questions at this stage? Nah, all good. Hand over.
So we might take a bit of a 5-minute break to switch over to the next prezo. I heard we had Mixie around. Do we have Mixie? Do you want to come and tell us about what Mixie is?
I can tell you about what Mixie is.
So I put you on the spot.
To get on this network. Now, who's got the updates needed on their Mac?
Well, that's me. So the plug doesn't work.
Okay. How do I connect in then?
With the BNZ laptop.
Oh, really?
It's a pain.
That's the same from
I'm just on the network. Sure I am.
This is our one Mac support guy. On every message that comes out on your Mac, it's like a different photo of him going like, haven't updated in like 10 days. It's like a real mad face. So we probably can't project that unless it's on there.
I can't connect. Okay, so I just need to send this to you.
Yeah, that's all right.
Talk amongst yourselves. How was everyone's day?
What happens when I push? I understand. I don't want to.
Question.
If anyone hasn't been along before, just to let you know, we have pizza coming at 5:30, so please stick around for that if you can. It's a good chance to do some networking and catch up with some of the other people here.
Slow today. Customer Wi-Fi. What's your address? Oh, yeah. I must have sent something to you. How many people have seen Mixie before? Right, brilliant. This is brand new. I will give you
Everyone's
that.
going, what the hell is Mixie?
What the heck is Mixie? Who is Mixie? I will just. Just trying to pick someone. I'm not used to it. It's just a little bit slow. It's saying anything about your network. Ah. it's just me trying to remember it, where it is. Yeah. It's not that one.
Hey, man.
Hey.
Hey. So you're in charge of video, I see.
Yeah,
How do you? I mean, is it you? Like, is there a YouTube channel or where
yes,
do you host
yes,
it?
yes. So if you go to awsug.nz, you'll see all of our networking there, our Facebook, our Slack channel, our YouTube channel. So this is live streamed on YouTube.
Oh.
The laptop.
Cool.
And the cameras are recording.
Hmm.
And we're capturing the audio to replace it later.
Ah, cool.
Yeah.
Cool.
So
Yeah, awsug.nz.
yep, that's the address where we keep everything. We have a very active Slack channel where you can peer with us when we are not here. Yeah,
I might be already a member of it. Like, I started coming to the meetups. It was just like Seb Kruger
okay.
and being like the first 3 or 5, and when Slack started too, I remember back then, and he put us all. Yeah, I guess it has to be the same Slack. Yeah,
Probably, most certainly, yeah. Most
yeah,
certainly it is the same.
I should check it out.
Yeah, so we
So like, what came first, AWS UG or the Meetup group? Do you know?
the meetup group came first, I believe.
Yeah.
Because initially, Seb and Scott used to run the meetup, just the two of them. Then when the company they worked with was acquired by Deloitte,
Yeah.
they decided to make the user group public, instead of being a company thing, to be like a community thing. So yeah, now we are a group of 16,
I see it.
and as a matter of fact, we are accepting new members. So if you would like to help us, be part of the organizers committee, we'll be soon opening for onboarding new members. So I believe this is one of the announcements that they are trying to copy paste over there to announce. But
Oh, yeah, that sounds good. It's a good
Yeah.
way to network.
Oh, it's not only that, right? No, it's also a way to give back to the
Yeah,
community.
true. Yeah, I always like kick myself, like I don't have enough experience, or I didn't have enough exposure to the latest technologies or whatever, and Seb was always telling me, man, when are you giving a talk? When you are giving a talk? Whenever I have something exciting, sure, I'll be more than happy to.
Well, the website has a form where you can, volunteer to speak for us.
Subject to present.
Well, no, you actually don't need
But
to.
down the road, it could be, yeah.
You don't actually need a subject. You could just come in and share, this cool thing that you found out, or this new feature that AWS brought up that you played with, or story from your team. We are finding hard to make these community driven. So it's not only companies sharing their products or their new things.
True.
It's actually us talking, how good or how bad something is working, and getting help from the peers, right?
Yeah, cool. I'll look into it then.
Yeah, this talk will be, on the matter, on the ladder, about how we can do things better on AWS, right? It's community driven.
I'm not
Choice.
I'm going to come last.
Sounds good.
Okay, cool.
Apparently I'm going to come last. Do you want to put me?
Thank you.
Hi, good evening, everyone. So I just thought today to talk about a little bit about what Ethan really is about decoupled design thinking. It's a very short presentation. You're welcome to at any point ask questions. There's nothing too complicated, or really nothing complicated. And it's really, in my work I see kind of regularly where customers, we're moving into a space. I mean, the whole thing about AWS, it's all, you always hear services, services. It's a service for this, and it's a service for that, and it's a service for everything. But when we design our systems, do we do that as well? And very often I find that customers sit in a situation where they start implementing their own technology rather than solving the business problem. They might end up writing their own event bus for some sort of thing, or their own database, and they do that. That's not it actually happens. So often when you catch yourself writing code, or if your team is writing code that's not business. That's not what you do, except if you're in the technology business, except if you are developing databases or security systems. That's a whole different story. But if you're writing a business system for a property company or some other company, then you want to make sure that the code that you write and the systems that you develop you focus your energy on developing a business problem and leave the heavy lifting to infrastructure. Now that's where AWS is amazing. I mean, I've been in IT for close to 30 years, and there was a time where you would spend weeks setting up everything just to get going. I remember setting up databases over weekends and fixing things, and now everything just works. But you need to know how to do this correctly to get the full benefit of it. So today I just want to start with just thinking about this decoupled design thinking, and if there's interest, I'd be happy to do a next presentation on how you would actually implement this. So this is really not so much technology centric, but more about the concept of, let's call it, event-driven systems. And because it kind of is one of the keys to unlocking a decoupled system. So this I was just kind of thinking about this a little bit and thought, this is the kind of things that I, at the top of my head, just quickly thought of. This is kind of what I thought AWS got right. So their systems are always independent. Everything does what it's supposed to do, and it only does what it's supposed to do. It doesn't do anything else. If you look at S3, I mean, that's the one thing that everybody knows. It saves objects, and you can get your objects, and it does that reliably, and it does it well. And from that, you can learn a lot from that. You want to, when you use the technology, you'll find that there's, for example, fit for purpose. You find something and nothing else does it better exactly what you want to do. In S3 or EC2, something like that, you want to grab that technology, use just that technology to solve a specific problem. And again, that's when you design your systems. You want to design your own systems, your own business solutions in the same way. So this is a very, very typical way that systems work. And this is a synchronous system. Basically what you do is the customer places an order, the order system calls the payment system says, yep, payment's okay, order goes through and the customer got his order done. And that's all fine and dandy. The problem with this kind of thing, that your order service needs to know about the payment service. It cannot work without the payment service because it needs to know about the payment service. If the payment service is down, the order service can't work. The order service can't keep the state of the payment service, so they both need to be available for this to work. Then it gets a bit more complicated. Over time, your order service will say, well, you want to send out an invoice, you want to ship the stuff that the person ordered. And now the order service needs to know about all of these things. Now let's say, for example, the shipping team goes and makes a change to how the system works. They deploy a new version. If you want to use the new version of the service, then you have to change the order service as well. If they didn't tell you that they released a new version and they're not using a versioned API, they could break your service. So you're sitting in a situation where the team that does the shipping service can actually break the order service. So basically, when we look at the challenges of having systems that know about one another. So when people write code, they often say, well, we're writing asynchronous code. I'm not waiting for a call to come back from my customer. So I'm calling the order service, but I'm returning before I get a response. And I say, well, I'm not blocking So I'm kind of doing it asynchronously, so I'm not affected. Well, yes and no. So maybe you're not blocking in time, so you manage to decouple your system in time. You're not dependent on that system responding immediately, but you are still dependent on the interface of that system. You're still dependent on the life cycle of that system when they release new versions. So by writing asynchronous code, you're solving one of the problems of tightly coupled systems, but you're not solving all of them. And effectively what you've got here is a system that I would call a distributed monolith. It's still a monolithic system. Yes, you've got separate services, but they all depend on one another. So we're doing microservices now. It's all separate. Yes and no. Because those services are still inherently bound to one another, so it's still a monolithic system. It's just distributed. So you probably increased your complexity and you didn't get all the benefits of having a distributed system. So how do you fix this? So basically we want to say, well, between our order system and our other services, we want something in the middle that takes care of the decoupling for us. Now, when we talk about decoupling, we can say we're decoupling based on our interfaces. So this order service doesn't want to be dependent on these interfaces. It doesn't want to be dependent on time. If this service is down for half an hour or for a day, you still want the order service to work. So it wants to be decoupled in time. Or if the shipping service takes 20 minutes to actually say, somebody maybe has to go and check the shelf, does the package exist? Yep, it does, and then they go and tick okay. So you might have a person that's actually part of the service. So before this thing can come back, it might take 20 minutes. So you don't want this thing to say it's decoupled in time. And you also want to be decoupling functionality. The shipping service might want to add new functionality. It mustn't break the order service. You want to maybe add new services. It shouldn't break the order service. So you need something in the middle that takes care of this. And your main thing here is that you're moving from a command-driven system to an event-driven system. So in the past, in the previous slide, our order service had to know of these services, and it actually tells these services what to do. It says, invoice, do this, payment, do that, shipping, do that. It's giving it commands, it's calling APIs on those services and telling it what to do. Now we're going to an event-driven system where these services just listen for events. This one just adds events. So it says an order has been placed. The invoice says, somebody placed an order. Does the invoice payment says somebody placed an order. Does the payment shipping services, oops, can't find that item. So maybe it creates an event that says item unavailable. Then the payment might say, oops, I got the item unavailable thing, so I'm reversing the payment. Invoice service says, whoops, I'm sending you a credit note. And the order service then says, oops, something is not available, update your card. And you typically see this quite often when you do online shopping and stuff like that. For a moment it might show that you go to the next screen and says, oops, sorry, not enough items. And that's the kind of thing that happens in the background. Because these systems have a bit of what they call eventual consistency, an event might flow through the system. It might be a while before it gets back to the front, and that's okay. So when you want to look at these in the middle, if you want to look at what would you need to do this event-driven systems requirement is for the kind of stuff that you need on your service. So is it important for these messages to be persistent? So for example, I place an order and the system goes down. Did it have to save that order before? Because that payment service might not be available today, and now your order's gone away. So yes, maybe this thing needs to be needs to be persistent. What delivery method do we want? Do we want this system to tell these systems there's a new message for you, there's a new event? Or do we want these systems to actually ask, is there a new message for me, is there a new message for me, is there a new message for me? Or you could go on saying, so well, we're subscribing to certain message queues and that kind of stuff. So there's lots of things to take into consideration. That's why you get different types of event messaging systems, and sometimes you need to combine them. So for example, I might use something that sends a message, like for example, I'm going to say, well, okay, I'm going to have SQS queue up these messages for me, as an example, and then once somebody's taken it off that service, then that message disappears, means somebody else can't take it, but maybe in your case that's maybe something that you want to do. So that's kind of where you want to think about the fabric that you want to use to deliver your events, what you want to use. So basically the decoupling benefits are both, as I mentioned before, decoupling in time, purpose, technology. So basically your services doesn't have to be written in the same technologies. You're not dependent on the APIs. You're not dependent on the development life cycle. And also blast radius. If one of the services go down, or maybe if you find that the invoice capture project, we're going to do a brand new project, that's okay. Only that service is affected, doesn't affect all your other services. So some of the technologies you want to consider when you look at something like this is EventBridge. EventBridge is amazing, I think. Basically, it's built on your old CloudWatch events. So rebranded, added some features, added filtering, and added rules to CloudWatch events, and now it's available as a separate service. It's about, I think, $1 for a million message or something crazy like that. And it can work between your system and also with external parties. So an external party can say, well, you can connect to my EventBridge and I can actually now start getting messages from that party. So for example, if I'm saying somebody in Salesforce, so well, every time order gets placed or something, I can notify you. So it's a very nice way to decouple your systems, and it's a very low cost way to decouple your systems. And EventBridge, as I said, what it does is it can do targeted delivery for you. So EventBridge might, in this case, let's say for example we use that, then you would have 3 rules in EventBridge. You need to have rule to my invoice system service, deliver the message to my payment service, deliver the message to my order service. And alternatives are, well, most of you probably know them well, Kinesis, simple notification service, simple queuing service, and then you could be creative on the way that you use other things. You could also use DynamoDB, anything that can store state, but there would be certain cases you might find that I want to keep an event for longer than one of these things can do that, and you can actually start developing your own middleware, but by just tying things together. You're not writing your own event bus, you're just putting the different. And that's it, short and sweet. Any questions from anybody? Nothing. Cool. Done. Eat pizza. Thank you.
Thank you.
Thank you.
Cheers, you obviously know this
Cool.
inside out. Cheers.
Thanks.
Sweet. So before we move out to pizza, there's actually a machine out there that it's
It's a
connected
nice
to
little
AWS.
robot, yes.
So
Now, did you get one of the presentations?
I did. I got 3.
Awesome. 3.
So-
Awesome. We could do this 3 times.
Might just stop that.
Yeah. So, I'm Linda. I'm from Accenture. I'm also a committee member here at the AWS user group. So, I help decide what's going on, and sometimes I decide to bring robotic AWS serverless cocktail makers along. Why not? Because, yes. So, last year we brought Mixie along, BC, I say, before COVID, as we do, when more people used to attend our user groups. And I know I'm hungry for pizza and everything. Cool, thanks. So, what is Mixie? Why? Why would we make a serverless cocktail maker? Just sometimes in IT, we need something tangible to look at. We need something physical to actually tell us what is happening. And actually, Mixie was invented for AWS reInvent in 2017, and is a product of one of our sections, which does, it looks like this. What is Mixie? Yes. A drink dispensing robot takes your order and makes you a drink, completely using AWS services.
Yes.
So this is really good. Why server? Because after, I'm not even going to tell you how many years as a Microsoft engineer, I'm sick of being woken up at 2 o'clock in the morning to reboot a server to get someone's code working. Let's just let somebody else do the services. It's cheap, it only runs when you want, you know, all the benefits of serverless. How can I go through those? Now, this is a stock photo of Mixie. The one you'll see outside, we actually turn the bottles the right way so nothing leaks out. That was design 1. I think design 2 is what we've got. Design 3, I think we're going to actually stick some glue so the 3D printed parts actually stick together and stay together better. It was, inspired by design thinking, spark innovation. Mixie is our conversation starter about serverless. You know, all the things we could do. It was built in just over 4 weeks. Version 2 was another 30 days, sorry. Version 2, industrial design, I take them with a pinch of salt. My colleagues who built it, it's a little bit not so robust. This is us demonstrating Mixie at a grad day we had in Accenture. As you can see, we just set it up with Alexa, natural language processing, that is the AI. We also can use recognition, another AI component, to recognize you. This is a bit closer up version of Mixie. We have Mixie out there, ready to go, but you might want to be able to peer. Unfortunately, it's in a small space, so we'll set it all up. Now, Mixie is made up of a number of components. So peristaltic valves suck the liquid out of the bottles, right? Put them into your drink. What we actually tell Alexa what kind of drink we want. We have a private Alexa skill on our Alexa Echo, and we just launch Mixie and we can tell Mixie what drink we want. It goes. Actually, I'll get to the architecture. There you go. This is the small version. We actually have a CloudFront-based website that, using Cognito, you can log in, choose a drink. I don't have my iPad with me today to show you. Things are, CloudFront with S3 behind it. Goes through to Amazon Lambda, AWS IoT. Uses the Raspberry Pi. I can wax lyrical for hours on all the different things that you can do with a Raspberry Pi, other than stick them in your drawer and forget about them. And the Raspberry Pi drives those peristaltic valves, which are quite often used in food or medical systems, to suck the liquid out and make you a drink from whatever. And the Raspberry Pi has the recipes on it, as well as DynamoDB. So we talk to Alexa. Alexa goes through to Lambda, DynamoDB. If we had a camera hooked up, we could actually have a camera, and once you've actually got your drink, you've gone away, you've come back in your conference, for example, Mixie would actually recognize you and say, did you want another Stormy Cloud or Evil Cloud, or we've actually got quite a few different names out there, you'll see. Mixie will also tell you a joke or a fun fact. You can say, no, a fun fact. Would you like a joke or a fun fact? They're not very good jokes, just don't, you can do the groaning like it's a Christmas cracker thing. That's it. So I know we're all hungry, so questions about Mixie. I think this is the demo time. Last year when we demoed it, we actually had Mixie in here, but I need to go out there and turn Mixie on, possibly try today rebuilding it a little bit just to get some of the valves which had been pulled apart by one of my colleagues, and Mixie has been packed away over COVID times, and we've just dusted her off. And yes, I call it a her. Dusted her off mostly because the Alexa is a female voice. So has anyone got any questions about this?
Have you worked out the cost of an average drink?
Pretty small, and I certainly am going to reiterate, it's not going to put anyone out of business here either. Mixie does take a little bit longer. We have had queues. I did take Mixie along to, we had a girls in STEM for 11 and 12-year-olds, and I had a queue out the door because Mixie does take a little while, and all they wanted was a lemon shadow, which is a mixture of Coke and lemonade. Because obviously they don't get that anywhere else, not allowed fizzy drinks, so Coke and lemonade. Mixie was very popular. It is so cheap to run because these services are only, Lambda, event-driven service, only kicks in when we need it to, and we have so many, thousands of API calls free per month. This is cheap to run. We're not running a server in Spark's data center, 24/7 just to run this when we want. It just runs when we want, automatically.
Do you have real cocktail recipes?
I do have real cocktail recipes. However, I am going to tell you that I brought the whiskey. I didn't bring vodka because I can't get pump 0 and 1 working properly. So I'm going to tell you the vodka recipes are off. We have non-alcoholic, and we can have alcoholic. Don't tell anyone from the police here, or the licensing trust. No, it's yeah. So that we do have alcoholic recipes and we do have non-alcoholic. And if we wanted to change, people who have, when we first got Mixie in, Mixie didn't mix a mean drink. As in, it said if you go into the Raspberry Pi and check the recipe, it said 35% alcohol. However, Keith could attest. Keith from AWS, who's just got out to get the pizza, can attest. Yes, mixed a mean drink, and it seemed to, some valves seem to pump better than others, I think. So, yeah. By accident. So, I mean, mix is really good. And as I said, Raspberry Pis, they normally sit dusty in our drawer until we use them. And this is one way. You know, you have one team building the actual physical garage project device, which, as I said, it does look like it's knocked up in someone's garage, and you have another team doing the code. This is how we make things fast. And we design thinking, we think, what do our customers want? A cocktail maker. Of course they want. That came, and that's why people do, you know, you get to what's your end product, and then you build to what you can do. So I think the team here just thought something fun for reinvent, something that kind of is different, has all these AWS services, voice activated from Alexa, natural language processing. And then when people came back, because they had a camera hooked up, it would have the recognition as well. Which we can't really, I don't know how they got away with it. I suppose you sign a thing saying, I don't mind you keeping my photo for a few days. Because to me that would be just a nightmare, but that's it. So that's what Mixie is. So what we're going to do is, I think the pizza's arrived. I don't know, I'm sorry, yeah.
Cocktails also sometimes require mixing and shaking the right.
Oh,
Have you
yeah,
created
okay, you know. I'm good, but I'm not that good. Hey, we were thinking even maybe of getting, you know, if we did actually take Mixie to a conference, maybe we could get a quick site dashboard of what the favourite cocktails were, or Sumerian. How about a Sumerian creepy looking Soul Machine equivalent digital assistant to ask you what cocktail you wanted or what drink? You know, maybe, you know, if anyone volunteers, go for it. I'm happy for you to come and design something to go in front for either a dashboard for visualization of who drinks what kind of drinks, and, you know, Sumerian to ask you, what else? What else could we put in front of Mixie? So this is it, cheap, but it's a conversation starter, and feel free to, then Mixie will hopefully mix the drink. As I said, I've had to fix a few valves today, so it should work. Oh my gosh, that would be awesome. Hook it up to Deep Race somehow. Pre-order. Yeah, pre-order the Uber. Yeah. Or better than Deep Composer, and like make Mixie play music as we get our drink. What else? It's a piece of pizza, but we'll actually go to Mixie on.
Sweet. Well, thanks to our speakers today. Thanks to AWS for the pizzas, Accenture for the whiskies, and BNZ for this sweet ass venue. Cheers.
Cheers. Thank you.